So, welcome everyone to Chapter 2 of our CompTIA Network Plus journey, which is about infrastructure and documentation. Now, I know documentation might sound about as exciting as watching paint dry, but trust me, this stuff is the backbone of every network you're ever going to work with. So, think of it like the instruction manual for IKEA furniture, except when you ignore it, the whole network falls apart instead of just a wobbly bookshelf. So here we go. This slide starts talking about the components of structured cabling. So with regards to structured cabling, the ANSI TF 568 standard, obviously that's a mouthful, right? It's basically the rules of the road for how we run cables in buildings. It's like having a universal recipe for network wiring. The key thing here is that structured cabling works with any type of media, whether you're running copper, fiber, or even if we invent some crazy new cable in the future. It's like having a toolbox that works for any job. And notice it assumes a star topology. Everything radiates out from the central points, kind of like spokes on a bicycle wheel. Here's what a real structured cabling setup looks like in a campus with multiple buildings. See how everything connects back to the central points? It's like a family tree, but for networks. Each building has its own mini hub that connects back to the main distribution point. And notice that we've got acronyms everywhere. We're going to be looking at a bunch of acronyms this chapter. We've got IDF, we've got MDF, we've got, I think EF is on there somewhere. Actually, it's spelled out on that one. But don't worry, we'll break all these down eventually during this chapter. Think of those acronyms as different levels of corporate hierarchy. We've got the big boss, we've got the middle management, we've got the local supervisors. So let's just start defining some of these acronyms. If you see EF, that stands for entrance facility. This is where the outside world meets your network. Think of it as the front door to your house, but for the internet. Next, we have DMARC for demarcation point. This is the you break it, you bought it line. Everything on one side belongs to your internet service provider. Everything on the other side belongs to you. It's your responsibility. It's like the property line between your house and your neighbor. The MDF is the main distribution frame. That's your network central command center. If your network were to like a pizza restaurant, this would be the kitchen where everything gets coordinated and made. Data room is also called a data closet or a telecom room. Don't let the word closet fool you because some of these rooms are ginormous. They can be very, very big. More important pieces of the puzzle. We've got three more things here. We've got the rack. The rack is really like an expensive bookshelf, but instead of books, it holds all of your network equipment. Everything has a specific size, and it fits together like Lego blocks. Next, we have patch panel. This is like the ultimate junction box. It's where all your cables come together, basically to party. You know, it's instead of having cables running directly to every piece of equipment that you have in your network, which would be a nightmare, everything connects to the patch panel first. And then we got VoIP telephone equipment, which is voice over IP. Back in the day, phones used to have separate wires. Those days are gone. Now your phone travels over the same network as your goofy YouTube videos you watch. It's voice over IP. It's a relatively common technology. This is the inside view of how structured cabling works within a building. See how we have horizontal and vertical runs. It's like the circulatory system of a building. Arteries and veins carrying data instead of blood. The IDF on each floor is like a local post office. It sort of directs traffic for that area. And the entrance facility, also here it's spelled out. You could also, sometimes it says EF. That's where the internet highway connects to your building's local road. So that's where it comes into your center. So on the end user side, we've got some more things that we need to make sure we understand. We've got the IDF, which is the intermediate distribution frame. So these are like network relay stations. They take the signal from the main hub and distribute it locally to each floor or section. We've got the work area, where obviously is where all the magic happens for the end users, which is desks, printers, anything else that needs IP addresses nowadays. I've seen crock pots that need IPs. I've seen refrigerators, coffee machines. So that's your work area. And then wall jacks. The standard for wall jacks says that each wall jack should have at least one voice and one data outlet. Though most of the time these days, most voice outlets just carry more data since everything is digital anyway. So for rack systems, we've got 2 posts, we've got 4 posts, and we even have 6 post varieties. Think of the posts like legs on a table. The more posts means the more stability for the heavy equipment. In this situation, height is measured in U units. 1 U equals 1.75 inches. The standard rack is 42 U tall, which is about 6 feet. Why 42 U? Because 42 obviously is the answer to life, and it's the answer to the universe and everything else in between. Or at least that's what some network engineers like to tell themselves. Width, on the other hand, is standardized at 19 inches, and that's not random because it dates back to early telecom equipment. It's like how railroad tracks, the width of railroad tracks can be traced back all the way back to Roman chariot wheels. That's why railroad tracks are the width that they are. Next slide, we've got where we get into climate control, something you may not think about. This is called the hot aisle and cold aisle design. Cold air gets pumped in from the bottom, equipment sucks it into the front, and hot air gets blown out the back. The hot air rises and gets vented out at the top. It's like a very expensive, very technical version of opening windows for cross ventilation. And this matters because overheated network equipment is about as reliable as a teapot full of Jell-O. It's just not very reliable. This slide talks about something that most people still don't think about, and that's the way that air flows through a rack, and specifically through a switch, because some switches are designed for port side intake, which means the switch is meant for air to hit the ports first and then exhaust out the other way. And then some switches are backwards. So it's meant to bring in air from the back of the switch and flow through the ports. So you need to make sure that you match your switch airflow to your rack design, or you'll be fighting, against your own cooling system. It's like trying to blow dry your hair while someone else is using a fan to blow it in the other direction, which obviously I don't have an issue with. So let's talk about cabling a little bit. There are 3 main types of cables. We've got patch cables, which are short jumper cables, usually under 10 feet. Think of them as the last mile of your network connection. We've got horizontal cabling. This cabling runs from your work area to the nearest data room. Basically, it's kind of like your neighborhood streets of the network. And then we've got backbone cabling. That is the interstate highway connecting major distribution points. It carries the heavy traffic between buildings, between floors. It just depends on what your network looks like. Remember, many network problems start with a bad cable install. Something as simple as a $2 cable can bring a $1 million network down. So make sure you're aware that cables are kind of your first defense. This is a diagram of horizontal cabling. Notice the distance limits in horizontal cabling. Less than 90 meters from the data room to the wall jack. So we're looking at 270 to 300 feet max before you start losing signal and quality. And then less than 10 meters, 30 feet-ish, from the wall jack to the workstation. Why do we have those limits? Well, because signal quality degrades over distance. It's like playing that game of telephone where one person says something to the next person and then they keep repeating it to the person next to them down the line. And the last person at the end, when they explain what they just heard, means nothing compared to the original person that learned. So, that distance, the longer that travels, the more garbled it gets. So make sure you understand these limitations with regards to horizontal cabling. So with cables comes cable management. Make sure that this is kind of like an art, actually, when you look at some of these systems in data rooms. Termination, make sure that you don't leave more than 1 inch of cable exposed. Too much exposed wires, like having your shirt untucked, honestly, it looks sloppy and it can cause some problems. Bend radius is every cable has a minimum bend radius. So if you bend it tighter than that, you're giving data a traffic jam. So make sure that you're not bending it beyond what the bend radius is. Continuity testing is something you do to make sure your cable's working and that it's basically each end is terminated the correct way on both ends and it tests well. Think of like a cable tester as a stethoscope for networks. And then loose cinching, don't strangle your cables with zip ties. They need room to breathe, just like we don't yank down on our belt and, with our pants and make our pants super tight. This is a similar thing with cables. And then lastly, cable coverings and conduits. Obviously, you need to be careful with your cables. You need to make sure that they're covered up and they're not just lying on floors and across things. Otherwise, you're setting yourself up for some problems down the line. So more cable management things, EMI sources. You need to make sure you keep cables 3 feet away from fluorescent lights and other interference sources because electromagnetic interference is like having someone shouting while you're trying to have a conversation. It causes problems, and it will cause problems in your network. Plenum cabling, you need to understand that if cables go above ceiling tiles or under floors, they need to be rated for fire resistant. They have a fire resistant coating on them because regular cables can release toxic fumes in a fire. So make sure that if you're running cabling above a ceiling tile or below subfloor, that it's rated for plenum. It's called plenum cabling. Grounding, make sure that your cables are correctly grounded because obviously if not, you're going to have electrical problems, and it also protects the equipment. You don't want the equipment going down. Basically like having a lightning rod for your network. So it's just, it's the safe thing to do. Cable trays is back to cable management. You need to make sure you use proper cable management because otherwise it just looks like just a bowl of spaghetti and it's hard to trace things back and it just becomes a mess. Take pride in what you do. Make sure things are in a nice, orderly manner. With regards to cable management and with regards to documentation, you want to make sure that you document everything because if you don't document something, it's going to come back and bite you in the rear end. Trust me. You need to make sure that documentation is accessible because if only one person knows where the documentation is, you're going to have a single point of failure, and you always want to try to avoid single points of failure when you're dealing with networks. You need to make sure that you update documents as you progress and as things change. If you're on a project, make sure you're updating that document as you work through your project. Don't wait until the end. Document those changes immediately because you'll forget, something will come up. Make sure you label everything, every port, every cable, every patch panel connection. If it's not labeled, it may as well not exist. So make sure you label. And then color coding is also another important part of cable management. Use different colors for different purposes. It's like having a color-coded filing system. It just makes things simpler to know that a certain color means a certain type of cable going out. Next, data rooms. Looking at just the environment of the data room, you need to make sure that the data room has a separate climate control system in order to keep your racks running happy. Computers are like people; they work best when they're not too hot, not too cold. Make sure that your environment in that room is monitored: temperature, humidity, airflow, sensors, 24/7. Think of that like your smoke alarm for your data room. You want to make sure that that environment is as controlled as possible. You also want to make sure that that room is locked. Security is important. Lock the doors. If you have cameras to put on it, you can. It's just like your car. You wouldn't leave your car unlocked with the key sitting in the seat or even in it. So you need to make sure you secure your network room. And then last is the ICS, the Industrial Control System. This is where you have sensors and software that monitor everything. Some have it, some don't. But honestly, if you have it, it's like having a butler who never sleeps, always knows if something's wrong. So if you're fortunate enough to have something like that, it certainly helps your environment. So back to documentation, you think about why do we want to document everything? Documentation is extremely important. There's three reasons why documentation is important. Number one, efficient communication. Good documentation means that everyone speaks the same language. No more playing 20 questions to figure out how something works. Two, faster troubleshooting. When something breaks at 2 a.m., documentation is your best friend. It's like having a map when you're lost. If you don't document properly and effectively, you're going to have a longer time figuring out what's going on. And then lastly, future reference. 6 months from now, when you don't remember why you did something or something specific about what you did, documentation is like leaving notes for your future self. So these are a couple of more reasons why it's important to document. We're going to pivot a little bit. We're going to look at network diagrams because network diagrams are like pictures. They're worth 1,000 words. And as we learned in chapter 1, we've got a couple of different types of networks. We've got the physical network, where it shows where things are physically located. Logical network shows you how the data flows. It's like the difference between a floor plan in a building and the electrical schematic of a building. Network mapping, we've got tools like Nmap that discover what's actually on your network, and tools like that are important because it's like taking inventory of your network neighborhood. And then lastly, Cisco symbols. Cisco symbols is very important because it's really the industry standard for diagram symbols. Learning these Cisco symbols is like learning the universal language of networking. So here's a diagram of a network using standard Cisco symbols. Each symbol represents a different type of device, whether it's router, switches, firewalls, servers, workstations. Notice in the diagram, it shows the logical flow of data from the internet through the firewall to the router, through the switches, and then finally to those end devices. It's like a roadmap showing all the stops that the data makes on its journey to the end user. This is a diagram of a rack diagram. It shows the physical layout of equipment in a rack, which is incredibly useful for planning new installations, troubleshooting, so you know exactly where things are, managing power and cooling requirements, and ordering the right equipment when things go sideways. It's really like having a blueprint of your network closet. Without it, you're really just playing a very expensive game of Jenga. Some operating procedures with essential documentation. Network connections are important. This is how everything connects together. Inventory management is what equipment you have and where it is. IP address utilization is which IP addresses are used where. Vendor information is who to call when things break. SOPs is standard operating procedures. These are the step-by-step instructions for common tasks in your network, and they are like recipes. They ensure that everyone does things the same way and they get consistent results. So standard operating procedures are important, especially if you're working with a team. Inventory management's the next slide. And inventory management isn't just about counting equipment. It does simplify maintenance because you know what you have and you know where it is. It helps with cost analysis because you can see what's working and what's not working. It speeds up troubleshooting. No more hunting for that spare switch. Think of it like the ultimate, where did I put that prevention system? So inventory management is also a key component of networking. Next slide, we're getting into labeling and naming conventions. When you look at naming switches and cables and things like that, think about if you look at a switch and it's just named switch 1. That tells me absolutely nothing. So it would be much more descriptive and easier for you to locate if you said like Southwest switch, or just switch 1, maybe floor 3, east hallway. That's going to be a lot more beneficial for me if I'm trying to troubleshoot than just putting switch 1, switch 2, switch 3. You need to think big picture to details. Start with a location, then get specific. Another thing you need to consider is security. Don't put sensitive information on those labels. Most of the time, normal, average people aren't going to see this room or be in this room, but just in case someone's able to get in, you want to make sure you're being safe with the way that you label. Color coding everything is also helpful. Different colors for different purposes is a quick visual representation of identifying some things. And then label both ends. Put a label on the port, put a label on the jack, both ends. Because that makes it a lot easier to find as well, especially when you're getting into tracing wires back from, classrooms or offices back to the switch. Here's a picture of what good labeling looks like in real life. Notice we've got a couple things here to mention. We've got color-coded cables. We've got red. We've got green. We've got white. There's some orange, looks like fiber back there. Make sure, also another thing that you can see is that the ports are clearly labeled with a naming schematic there. And notice that the tags are labeled as well. Then those tags represent, what the purpose of the cable. Once again, you may think this is overkill, but if you're troubleshooting a problem in the middle of the night, you'll thank whoever took the time to label these properly. It's tremendously beneficial. So, pivoting a little bit here, and we're looking at the business documents, which is the paperwork side of networking. Some of you may deal with this, some of you may not. It just kind of depends on what environment you're in. This is something that I deal with as the Director of Technology for a school district. So let's go through these quickly. RFP is the request for proposal. It's like saying, hey, vendors, what can you do for us? MOU is the Memorandum of Understanding. This is like, hey, we're thinking about doing business together. Let's hash this out and let's create some sort of agreement. MSA is a Master Service Agreement, which basically dictates the rules for how you're going to do future deals. Statement of Work is SOW, and this is specifically, here's what you need to do. SLA, Service Level Agreement, and this is, your expectation of what level of service that you expect, okay? All of these things, think of these as like legal frameworks that keeps everyone honest and everyone on the same page, because most of the time when you're dealing with these, you're dealing with a third party, a contractor, an outside vendor, and you want to make sure that you're on the same page when it comes to these documents. This slide, we're talking about what happens when something happens to your network, because it will happen. More acronyms here. We've got MTBF, mean time between failures. What is the average time between the failure in whatever's failing? So it's how long equipment typically runs before breaking. Think of this like the odometer on your car and taking the mileage of between when something breaks on your car. The second acronym is mean time for repair, which is MTTR. That's how long it takes to actually fix whatever is broken. And obviously the goal is to make that as short as possible. Redundancy is having backups so that when one thing fails, another takes over automatically, which is a nice thing to have. And then we mentioned earlier, we want to eliminate the SPOFs, which is the single point of failure. That's the one thing that can bring everything down. So our goal is to make sure we find these and try to get rid of as many as we can. This slide is a diagram of redundancy in action. In this diagram, we've got two separate paths to the internet. And notice if one of them fails, the other one automatically takes over. It's like having two different routes to go to work. If one road is blocked, you can take the other route, which is common in these parts these days. The key is making sure that both paths are truly independent, not just different cables with the same provider. So if they're completely independent of each other, that's what's best, because if one goes down, you can pivot to the other one. Continuing in the anticipating failure, two ways we can handle backup equipment. We've got hot spare, which means it's already installed. It's ready to take over instantly. It's like having a co-pilot ready to take over the controls. And then we've got cold spare. Cold spare is sitting on the shelf. It's ready to be installed when needed. It's kind of like having a spare tire in the trunk of your car. Something happens to your tire, you've got it on hand. You can plug it in if one were to fail. Hot swappable equipment is designed to be replaced without shutting the system down. It's like changing a light bulb. The power stays on while you swap parts. Very nice. Next slide, we've got life cycle management. Everything has a life cycle, including networks. We try not to think about these things because it's sometimes depressing, but these are some things that you need to think about when you're designing networks and putting networks together and just thinking about your network in general. So when we look at the life cycle of a network, we've got, it mentions a few things here. It mentions requirement analysis, which is what do we need? Design planning, how are we going to build this network? Development and testing, let's build it, let's test it. Implementation, let's put it into production. Documentation and maintenance, let's keep it running. And then evaluation, how did we do? What's next? It's like building a house. You plan for it, you build it, you move in, you maintain it, and then eventually you either have to renovate, you have to move, or you have to rebuild. So that's kind of the life cycle of a design process of designing, implementing, and maintaining components of your network. And then here's a graphic that shows that it starts with the orange piece of the pie with requirement analysis. Notice it's a circle. It never really finishes it. After evaluation comes a new requirements, and the cycle starts again. Once again, it's like maintaining your car. You don't just buy it and forget about it. You got regular maintenance, occasional repairs. You've got to change the oil. You've got to put brake pads on. You've got to change your tires. If you don't take care of those regular maintenance things, you're going to do a disservice to the vehicle. So this is a diagram that shows the life cycle management. Continuing with that, configuration management keeps track of how everything's set up, and that follows the stages that are listed on this slide. We've got discovery, which is what do we have? We've got version control, which is what version is everything. Monitoring, which is everything still configured correctly. Automation, can we automate routine changes? Auditing, let's verify everything that's still correct. So this process, this configuration management, think about it as really kind of like a detailed diary about your network. It remembers every change and it keeps everything organized. So it's important to make sure you're understanding of what configuration management does. All good things must come to an end, with the life cycle. And we've got more acronyms, believe it or not. We've got EOS, which is end of support. This is when your vendor stops providing support for a product. It's like when your car warranty expires. EOL is end of life. End of life is when the vendor stops making the product. Or, like if you have an older car, it's when the car manufacturer stops making parts for your car, which can be a little bit concerning. Decommissioning is the process of safely removing old equipment from production. And once again, make sure you document everything before you pull the plug, because you may need that documentation later. You probably will, so take the time to make sure you document. Staying with change management. Change management is about making changes to your network without breaking everything. It takes good planning. You need to make sure you're thinking before you're acting. It takes user communication. Tell people when services will be unavailable. Careful documentation. That seems to be a key. I've said documentation quite a bit. Record what you're doing and why you're doing it. Remember, the goal isn't to prevent all the changes. It's to manage them safely. It's just part of the life cycle of a network. We do have 4 types of software changes that you're going to have to deal with when you're running a network. Installation, which is when you're adding new software. Patching, which is fixing bugs or security issues. Upgrades, which is moving to a new version of something. And rollbacks, which is going back to a previous version when you upgrade something and it doesn't have the intended effect. So sometimes you have to roll things back. Hardware changes include adding cameras, replacing workstations, installing printers, upgrading phones. It's basically anytime you want to touch the physical network. So best practices for making these types of changes. Number 1, no automatic patches. Having automatic patches to your system is extremely risky. Make sure you test everything first. Secondly, evaluate necessity. Do we need to make this change? Do we need to upgrade? Do we need to patch something? Read documentation. Know what you're getting into. When you think it's time to upgrade or patch something, read the documentation about it to make sure you're doing what you think you want to do. See if there's any discussion boards out there and see if other people have had good or bad results based upon doing those things that you're considering doing. Test it first. Put it in an environment that's not a full-blown upgrade for everybody. Try it in a lab environment or a controlled environment. How big is the change? What's the scope of the change? Who will be affected by the change also is something to think about. Obviously, you want to make sure you schedule things wisely. Do it when people aren't on the network, off hours, overnight, depending on what the work schedule is of the business or the school. And then communicate. Tell everyone who needs to know. Not everyone needs to know, but some people may need to know. And it's better to be forthcoming than to not tell anybody and then something happened and then you got to kind of backtrack and pivot and share what happened and what went wrong. Some more things to think about when making changes is back up first. Always have a way to get back to where you were. Make sure you control access, meaning don't let users interfere during these types of changes. Hey, keep documentation. We've heard that a time or two because you're probably going to need it. Test it in real time. Make sure that it actually works. Restore access if you had to get users out. Make sure you get them back in if whatever you're doing was successful. And then if you need to communicate results, tell everyone how it went. If you need to, sometimes you will, sometimes you won't. And obviously, last one there, guess what? Document. So, universal principles for change. Make sure you follow proper channels. Use the established process. Don't go rogue on this. Make sure you're doing this the way that your team or your company or your school district has established a process for your team. Minimize the impact that it's going to have on your business or educational environment, whatever network you're dealing with, because you don't want to break something that people need on a daily basis. Obviously, you want to plan for success. Do it right the first time, type of thing. Guess what? Document change through the process. Future self, once again, will thank you. These types of things to think through as you're making changes are important, whether you're doing something small or doing an entire network. So it's a mindset of making sure you're kind of going through these checks and balances to make sure that you're doing things in a positive manner. Couple of terms with regards to change management. Project is a specific effort with a clear beginning and a clear end. As a school district, we try to take on projects during summer months. Sometimes we have to do projects during the school year, which is not ideal, but kind of depends on what kind of impact it's going to have. If you're in a business setting, it may have different implications. And then project management is being able to deliver those projects on time and to deliver them on budget and to make sure that all the requirements are met. Good processes protect everyone involved. They ensure changes are done safely and that responsibility is clear. So when documenting changes, here are some things that you may need. You may need a change request. And we're really kind of getting into more of vendor type of things. It kind of depends on your environment. But a change request is a formal request to make a change. Approval process is getting permission from the right people. Project management is following established procedures. Additional documentation could be network configurations. It could be IP addresses. It could be physical locations. Change closure means you're officially finishing the change process. This is all part of a paper trail that proves that you or your vendor did everything the correct way. So it's really there as kind of a checks and balances type of thing. So in conclusion, chapter 2, we looked at infrastructure, we looked at documentation. You heard the word documentation 411 times this chapter. Make sure that you understand that good documentation and proper procedures may seem boring, but they're really what separate professional networkers from really expensive disasters. The key takeaways is plan everything, document everything, test everything, always have a backup plan. Your future self and your users will definitely thank you. And I will see you for chapter 3.